Identifying quadratic functions. Alright, so a quadratic function is one that is curved when graphed, so it'll look like one of these, and it has the form y equals ax squared plus bx plus c, where a, b, and c are values, they're numbers, and y and your x are your variables. Okay? This curve that a quadratic function creates or represents is called a parabola. All right, and the vertex of the parabola is the highest or lowest point. Okay, so this would be the vertex of my red parabola. That's the highest point it reaches. This would be the vertex of my green parabola. That's the lowest point it reaches. Your parabolas are only going to have one vertex, and it's either going to be a maximum vertex if your parabola opens downward, because these arrows, they're just going to keep on going forever. It's never going to have a minimum. This parabola won't have a minimum. It does have a maximum. So that vertex is at its maximum point. Okay. Same with a minimum. If your parabola opens upwards, it's never going to have a maximum, but you can find its minimum. Okay. The maximum and minimum are just the y value. So the maximum on my red parabola is is going to be 1, 2, 3, 4, 5, 6, 7, 8. Okay, that would be the maximum value. The minimum for my green is going to be 0. Right, it's right on the x-axis. Okay, so the maximum and minimum are just the y value. The vertex is going to be a point. It's going to be a coordinate. So the vertex for this parabola is 0, what did I say, 8? Yeah, 0, 8. The vertex for this parabola would be at 1, 2, 3, 4, 5, 6, 7, 7, 0. Okay, vertex is a coordinate, maximum and minimum are just the y value. All right. Concept 1, we're going to be looking at how to identify quadratic functions. Okay, when we have an equation and we're trying to figure out if it's a quadratic equation, we are simply looking to see if our x variable has a squared sign on it. Okay, has an exponent that's a 2. If it does, then it's a quadratic equation. All right. If it has, sorry, I guess that's not necessarily the case. If the maximum degree is a second power variable, then it's a quadratic. If it had like x to the 4th, x to the 3rd, x to the 2nd, it wouldn't be a quadratic anymore. Okay, all of these you can see whether they have a number, right? Whether they have a constant, whether it's negative or positive, whether it's a fraction. Any of these that have the exponent, okay, even if it's the only thing there, these are all going to be quadratic. Okay, even if it's not quite in this form, if you have that quadratic, it's going to still be a quadratic because I can just move this to the other side. All right. If my x value is not squared, then it's not going to be a quadratic. If I have a 0 times that squared x value, it's not going to be quadratic because that'll just always be 0. And if my y is squared rather than my x, it's also not going to be quadratic. Okay, so this is what we're looking for. All right, if you see something in this form, or even if it's mixed up a little bit, but it still has that square on the x, it is going to be a quadratic. All right, so now if instead of an equation, we're looking at a table, we're going to be looking for something called the second difference. Okay, second difference. And this is in reference to when we did linear equations, we looked at the common difference, right? We said, okay, x increases by 1, and all of these increase by 1. Okay, so that's a constant change for my x. And then I'd look at my y and I'd say, okay, well, the difference here is a +1, the difference here is a +3, difference here is a plus 5, difference here is a plus 7. Okay, those are my first differences. All right, when I'm looking for a quadratic, I'm always going to have different first differences. Okay, these won't be the same. But my second difference, okay, which is when I basically take the difference between my first differences, all right, so 1 to 3, well, that's a plus 2, okay. 3 to 5, that is a plus 4, or sorry, plus 2. Okay, 5 to 7, that is a plus 2. Okay, I'm looking for that constant change for my second difference. Okay, and this is telling me that, yeah, the change isn't the same, but the amount that I change each of my changes by is the same. And I know that might be kind of confusing, but if you're looking for a quadratic, if we're looking at a parabola, okay, from here to here, there's not going to be very much difference. Okay, it's not going to change a lot. From here to here, it's going to change the amount that this changed plus some more. Okay, and from here to here, it's going to change the amount that this changed plus even more. And that plus is going to be the same. That increase in change is going to be the same. And that's what we're looking at. Okay, so let's do another one. Okay, so here I've got -4 to -2, -2 to 0, 0 to 2, 2 to 4. So I've got a plus 2. Okay, my x change is constant. All right, and that's again the first thing you're going to have to check, just like when we were doing linear equations. And then you're going to look at your change in y. So I go 31 to 7. Well, that is a decrease of 23. So no, 24. Sorry. 24. Okay. And then 7 down to -1. That is a, and we're doing a decrease. That is a decrease of 8. Okay, and then -1 up to 7. That's an increase of 8. And then 7 up to 31. That is an increase of 24. And here's where sometimes it gets a little tricky, because you have to make sure that you're accounting for your signs, and making sure that you are looking at your differences the same way. Okay, so -24 to -8, that is going to be an increase of 16. All right, because I go from a smaller number to a larger number, even though it's still negative. And then -8 to +8, that's going to be an increase of 16. And +8 to +24, that's going to be an increase of 16. Okay, so my second differences are the same, and this is going to be a quadratic equation. All right, so both of these ones were quadratic equations. Now I'm going to look at my last one. I still have a constant change for x. Right, it's still plus 2. Okay, and now it looks like I go from +16 down to 8, so that's a -8. And then an 8 down to 0, that's a -8. 0 to -8, that's a -8. And a -8 to -16, that's -8. Okay, so now I don't even have to look at my second differences. Okay, because I know my second differences are going to be 0. Right? There's no change from -8 to -8. There's no change, and there's no change. Okay, and while this might seem like, oh well, zeros, they're all zeros, they're all the same, this is what you're going to get in a linear equation. Okay, so if all of your values are 0, it is not quadratic. Okay, not quadratic. I'll just leave it at quad. All right, this is going to be a linear equation. Okay.